And then I want you to read through it and decide what you're doing in part A. Here are your choices. You're taking a derivative, you're taking an integral, or you're plugging in. Those are your three choices. So type it in, read through it, and then figure out what you're doing for part A. Okay, and actually I'll give you a little bit of time, see what you can do out of A, B, C, D. Any of those parts.
No, I'm about to work on homework 3. I need that homework. What?
Yes?
What was that big order?
Huh?
What was that big order? Was it
That was Wednesday. Well, I was in the lecture hall twice, so I don't know which day you were. The mock exam, that was Wednesday. I think so.
What was like that for me, dude? What we do by
Calculator.
That's fine, too.
Um,
I'm already done with school.
You're not finding an integral? Okay, so I want you to think about, what did they give you? They already gave you S prime, so what do you need to do? Plug it in.
I'm going to Oxford.
There you go. You're
Harvard.
I promise I'll work you website trying to
Okay. All right, so quick question on part A. It says, at time 0, is the height of the water increasing or decreasing? Normally, you would do a what? Normally, you'd take a derivative. However, what did they already give you? They already gave you S prime. Now, if this is the rate the water is changing, it would be millimeters per day. So if you want to label that, this is already a rate that the height is increasing. So for part A, all that you have to do is plug in 10. Now, when you label it, you should still label it S prime of 10, but then you're going to plug in 10. Now, where else could you do it if it's in your y equals? The table, right? So go to your table, scroll down to number 10. I see that it's 2.091. What does that mean that the water is doing? Going up or down? Up, because why? The rate was positive. Very good. So I would say the rate, oh wait, hold on. Crap. The rate, okay, hold on. I'm wrong. I should have read it. Okay, if it said, is the water increasing? That's what we just did. What does it say? Is the rate, is the rate increasing or decreasing? So if you took the derivative, you were right. Sorry, my bad. I thought it said if the water's height was increasing. Not what it says. So if I want to know if the rate is increasing, I do need to take the derivative. Oopsie. Okay, so math 8, d dx, alpha trace y1, and then we want the derivative at 10. Okay? But look at the way that it's phrased. It doesn't say is the water level increasing or decreasing. That would have been a plug-in. It says is the rate increasing or decreasing. So we did need to take the derivative. Okay, I got a positive value. So S double prime at 10 is 0.0573. So I would say at t equals 10, the rate is increasing because S double prime of 10 greater than 0. Okay? Part B. According to the model, what is the height of the water in the can at the end of the 60-day period? Now note, I know how fast it's increasing. I want to know the height. So that's an integral. Now, go back and read the paragraph. Was there already water in the can? A lot of times there is. Is there in this case? Says, how does it start off? Empty. So I would still be doing a version B, but I would be saying the height that's 60 is the height that's 0 plus the integral from 0 to 60 of my s prime of t. And then maybe it would be better to use the same letter, so I'm going to change those h's. This is an s prime. I don't know why they picked s. Seems like h would be better, but whatever. Okay, I want to make those match. So if it's an s prime on the inside, it should be regular s on the outside. And then from there, if it started off empty, I end up not really needing this. So you just integrate that in the calculator. Okay? So math 9, 0 to 60, alpha trace y1 dx. Okay, now I want you to think about, this is the height of the water. What are my units going to be? Millimeters. Very good. So 171, 8134 millimeters. Okay, part C is a little tricky. So you know it's an average rate of change. I want you to read it very carefully and see if you can set up the correct f of b minus f of a. Says, what is the average rate of change of the height of the water in the can over the 60 days? What is the average rate of change of the height? Should I set up s prime of 60, s prime of 0, 60 minus 0? No. What is that the average rate of change of? The rate of the height. Okay? If I use s prime here, okay, that's the average rate of change of the rate the water is going up. I don't want that. So if I want the rate of change of the water, the height of the water, what do I need to use here? Not s prime, but regular s, right? So I'm going to cross that out. That's not what they asked me for. They asked me for s of 60 minus s of 0 over 60 minus 0. Now, think about for a second, though. What does s stand for? It stands for the height. Do I already know the height from part B? What's s of 60? 171. What's s of 0 if it's the height at the beginning and it started off empty? 0. So it'll be 171.8134 minus 0 over 60. Now let's talk about units. On the top, the height of my can is measured in millimeters. On the bottom, it's days. So I would have done s of 60, which is the value I just found, minus s of 0, it was empty, over 60 minus 0 days. Okay? You can divide it out if you want to, you don't have to. But the weird thing is that your units come out to actually be the same. Okay? Alright, go down to part D. Says, assuming no evaporation occurs, at what rate is the volume of the water in the can changing at time 7? Indicate units of measure. First question, find given one. Okay, and then question that I had for you, we did a cylinder, yes? Why did I use the, okay, because they want the rate of change of the height, and the equation that they gave me is the rate that height is changing. So that's why I didn't want s primes, I wanted regular s's. In part B, because if I want the height, this is millimeters per day, so I would have to integrate from 0 to 60 to know how many millimeters it went up. Because I only wanted height is measured in millimeters. So the weird thing is that they gave you millimeters per day, so if I want height, I have to integrate. Okay? So for part D, I did one of these, it was actually in second period, so if you didn't watch the video, maybe you won't remember. But for a cylinder, it's a can. Are there really two? There's not really two variables, there's only one. Which one is fixed? The radius is fixed. Because think about, as my can fills up, is my radius really changing? No. Okay, if this is my radius, what did they tell me that the radius of my can is? 10. and it's 10 at the top, and it's 10 at the bottom, and it's 10 regardless of how full it is. So remember, that means that I can plug this in here and edit my equation to take the R out and plug a 10 in instead. Yes, ma'am?
Will you ever get the height of the actual height of the can? Because that's fixed, because the actual height of the can.
But remember, you're not measuring the volume of the can, you're measuring the volume of the water in the can. So when they're talking about height, they're talking about the height of the water, not the height of the can. Okay? So fill out your find given when. Okay, so it says, what rate is the volume changing? That would be dV/dt. Given, I'm going to just put a question mark for now. And then at what time do we care about? Time is 7. Now, since we weren't really given a rate, I'm going to just leave that blank for now. Let's plug into our equation, take the derivative, and then see what we need. Okay? So, derivative of v is called, actually, before the derivative we're plugging in. So it'd be 2 pi, what's my r? 10. And then h. Well, 2 pi times 10 is really 20 pi h, and now I'm going to take the derivative. Okay, but remember, why can I do that before I take the derivative? Because radius is always 10, doesn't matter. Okay, so derivative of v is what? Okay, or v prime. I'm going to put dV/dt since it's related to time. On the other side, what's the derivative of 20 pi h? Good. 20 pi dH dt. And now think about, if I want to know dV/dt, they must have given you this somewhere. Okay, what is dH dt standing for? The rate that what's changing? The rate that the height is changing. Does that sound familiar? What other equation stands for the rate that the height is changing? S prime. Very good. And you already have it in your calculator. So I'm going to put here that dH dt is the same as S prime of 7. Because what does dH dt stand for? The rate the height is changing. And that's maybe why they called it S, was to not have too many H's or something. Or maybe to trick you. Who knows? Okay, so look in your value. What is the value of the derivative that they gave you at 7 when I plug it in? Okay, I got 1.9169, and that's what I'd plug in there for my dH dt. Now, it says to indicate units of measure. This is the rate of change of volume. What will I put? Something cubed. What cubed? Millimeters cubed per day. Good. Make sense? Okay, so turn the page. Okay, next one. I think this was the FRQ from 2017. Okay, I'll read through it for you, and then I'm going to give you about maybe 8 minutes to do what you can do on your own. Okay, it says, a grocery store opens, it has 50 pounds of bananas on a display table. Customers remove the bananas at a rate modeled by this, where F is measured in pounds per hour. So I'm going to put that here, pounds per hour. This is already a rate. Then it says, after the store is opened, stores add bananas to the display table at a rate modeled by blah, 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 also measured in pounds per hour. Okay, so that one is also a rate. Okay, part A says, how many pounds of bananas are removed from the display table in the first 2 hours? Then part B asks you to find F prime and explain the meaning. So I'm going to give you about 10 minutes or so to work through, do as much of it as you can, and then we'll go over it together. One other thing I do want to point out, what was it? Oh yeah, is that what is this, the in or the out for F?
Out.
Yep, because customers are doing what? Removing the bananas. And then what are the store employees doing? They're adding them back. So make sure that if you type your remove as your Y1, your add back will be your Y2. Okay? So do whatever you can do. You okay?
He's tired.
You want a lolly? A lolly?
Bro, I heard that too. I was like, bro.
Even like a Molly.
Recreational drug.
First it was weed, now Molly.
You've accelerated.
You took some R, didn't you?
I literally walked.
Took some R?
Y'all are like
Only seniors. So we don't have, you have to like start at 9
Okay, do you know what?
Last night, I accidentally fell asleep at like 9:30, but I had to grade my algebra. So I woke up at like midnight. I was like, dang it. And so I had to grade from midnight until like 2:30 in the morning. I was gonna do it just like in the evening. And then I like, at 3, I was like, do I go back to bed? Like, check me.
Wait, so we did that so you could pay everything?
So, yeah, so the grading policy for Richardson is you're supposed to grade 7 within like a week. And so they test it last Friday. And a lot of them are failing and I don't know.
Yeah, no one does. Miss Jade, follow the policy.
I love to follow the policy. Do you want to suck her now?
I like him, but.
Yeah, so anyway, it was regrettable.
Miss Jade, this one's sweet.
Especially with like.
It is good.
Who made it? I don't know.
I hope you are. What are you doing?
She's like spamming.
The first one is grab.
Yes. Love it. I love it.
5 grind.
Look at Brendan go. He's on fire. Someone get a fire extinguisher. Can you crack that?
I'm surprised she did it. I'm surprised she did it.
one. I don't like this. Anybody else need a calculator?
I like Valeria,
I know. I want you to do it.
It was really good.
Actually, here,
I don't know.
because it's only saying how many are. So you're not wondering how many are on the table, just how many were pulled off.
No, Amanda did.
So what were you doing per day?
From my seat,
So if these are in pounds per hour, and you want to know how many pounds you need to do in, derivative would be pounds per hour squared. So, and then if you want it at 2 hours, then you go from 0 till. Did you want one?
That really does. It's for something? I put that.
There were even
It's kind of tough.
Okay, we're doing it, yes?
Yes.
Yeah, this is still it.
What are we gonna do with you? Yes. It would be so you would say the rate is increasing at whatever. Or if it comes out negative, you'd say the rate would increase. And then quick thing, if it's decreasing and you say that word, don't also put a negative sign. So like if it's like -6, don't say it's decreasing at -6, say it's decreasing at 6.
Wait, why did you say remove an ad?
Because there are 2 rates, so one of them is the rate customers are pulling bananas off the table, and then,
But we still use both of them, right?
yes.
Okay.
Well, so for part A though, do you use both of them? You
Well, I haven't
only
read it.
want to count the bananas that are removed,
From Silver.
so you would only be using. But
So we have, like,
eventually you
another
are
5
to
minutes
use
to
both.
use.
The bottle cap, it's like a kind of like a shaver, I guess.
Did you put Albert on?
Yes, ma'am. Okay, so you don't want pounds per hour though. Oh wait, hold on. Yes. Well, okay, which one you subtract? You want to do in minus out?
Yeah. So, the question I have is, how would you write it? You just put, it's not like, what is it, 5 minus?
So you could do it two ways. The way that I'm gonna do it is I'm gonna find G of 5 and F of 5, and then I'm just gonna compare and say which one's good. That's how I'm gonna do it, but you could do it your way. You would just say like G of 5 minus R of 5 plus F of positive. That would be fine too.
But you think it's good fair.
Okay, what are we doing in part A, Elizabeth? How many pounds? And do you have just the first function?
I completely forgot about the whole thing.
Is that going? No? Are you working back there? Yes? Don't plug into, that'll give you pounds per hour. What do you want? The number of pounds. So if this is pounds per hour and you want to know how many pounds, what do you need to do? Derivative would be pounds per hour squared. So if you want, no, you need to do an integral. So if you're going from pounds per hour to pounds, that's an antiderivative. Honestly, I don't know if those are safe to eat, so I'll bring them on Saturday. Okay, no, I didn't. Shut up. Why would someone give me cheese balls as a graduation present? Okay, so for part A, how many pounds of bananas are removed? What do I do with pounds per hour if I want pounds? Plug in derivative or integral? Integral, yeah, for part A? And then you should have gone from 0 to 2. And then which function if I want to know how many were removed? F of t. Question, should I include the 50 that were already on the table? No, they only want to know how many were pulled off of the table. So what did we get for that? 20.051, good. Now, should I round if it's pounds of bananas? No. Okay, they will tell you if they want you to round. If it was the literal number of bananas, probably yes, you would have had to round it. But since it's in pounds, it makes sense to have part of a pound. Okay? Part B. You should have found the derivative. What did f prime of 7 come out to be? Positive or negative? Negative 8.1195. Then it says using units, explain the meaning. Okay, so I want you to think about what did F already stand for? The rate that customers were what? Okay, sure. So at time 7, then we're going to say the rate customers removed bananas. No, I think they... Hold on, I'll read yours in a second. Rate customers removed bananas is increasing or decreasing? Is decreasing. Actually, don't abbreviate that on the real IP test, so we won't be lazy. Okay, is decreasing at a rate of what? At a rate of 8.1195. Now, think about units. I already had pounds per hour. What are my units for my second derivative? Pounds per hour squared. Now, one other thing, I know I've said this, but in case you didn't hear it, if you say decreasing, don't also put a negative here. Okay, because then it's like, I didn't not do my homework, and then it's like, you lose it. So just don't do it. Okay? Yes? So it depends on what you're measuring. So if you're measuring volume, that's measured in units cubed on top. Versus if it's like here we're measuring bananas, that would just be measured in pounds. Now if it was area, it'd be like pounds squared. Then if it was volume, it'd be like pounds cubed. Obviously that doesn't make sense when we're talking about bananas. But that's why the top units change, is if it's area, volume, or just a distance. So like height would just be in like centimeters. Area, centimeters squared. Volume, centimeters cubed. Okay? Alright, part C. Is the number of pounds of bananas increasing or decreasing at 5? Are you plugging in or taking a derivative? You are plugging in. So you would go into your table, if you haven't already, go into your table at time 5, and I want you to find f of 5 and g of 5. And then after you find those values, you're going to determine which one's bigger. If the customers are removing at a greater rate than the employees are putting the bananas back, overall it's going to be decreasing. Okay, if they're putting them back faster, then it's going to be increasing. So, have we found those values? How fast are they being removed? 13.796, and they're being put back at 11.533. So overall, we would say, what's happening to my bananas? Okay, this is the removal rate. This is the add back rate. They're decreasing. Very good.
Just subtract that 2.
And say it comes out negative. That'd be fine. Okay, so I'm going to put at time 5, pounds of bananas is decreasing because the bananas are being removed we'll say at a faster rate than they're being added back. Okay. At time 5, the pounds of bananas is decreasing because the bananas are being removed at a faster rate than they're being added back. Now, I also would put this f of 5 greater than g of 5. Okay, just in case that's where your point comes from, I'd do it in words, I'd do it in math. Yes, ma'am. Camille? Because it's already a rate, that's correct. Correct. You got it. Okay, look at part D. How many pounds of bananas are on the table? What do we need to do for that one? I want pounds of bananas. I have pounds of bananas per hour. What am I doing? Integrals. Now, were there already bananas on the table? You have to count those then. How many were already there? 50. What am I going to do with the integral for f of t if those are the bananas being removed? Minus the integral for f of t. And then I'm going to add the integral for g of t. Now, look very closely at your equation. If both of your times are 0 to 8, you got it wrong. So I'm going to give you a second to try to figure out why. Go back and reread the question. They should not both be 0 to 8. Okay, what does it say? After 3 hours, the store employees started adding the bananas back. So were they adding the bananas back the whole time? No, and look at your domains here. When did the customers start removing? At 0. When did the employees start adding them back? Not till 3. So your first integral should be 0 to 12 because customers have been removing them the whole time. But the add back equation, you have to use the domain. You can't start till 3. And actually this should not be a 12. What should it be? We want the number of bananas at time 8. So fix that for me. So I'll go 0 to 8 on my removal, but I'll only go 3 to 8 on my add back. Okay, and then how many pounds of bananas? You should get 0.3473. Okay? Alright, last one that we're going to do as a group. Turn over. You have an area and volume. Okay, the very last question in your notes. Okay, so you are now doing this one. Last one. Go ahead and type them in. Okay, you have a revolving and then a cross sections perpendicular. Okay, and an area. So that's like the last unit that we covered. What AP test is on Monday? Are a bunch of y'all taking it? Raise your hand if you're taking it. I'm just curious. Okay. All right, you're doing the next one, please. Oh, you're just telling me. I thought it was like a second question. I want you to use Okay, do this math then. Let's do, okay, you do the math.
Looks like you need that. You almost captured today.
Are you observing? I didn't know if that was why you were not feeling good. I was gonna be like.
Observing wrong. Observing wrong.
Just asking.
I'm Jewish.
That's wonderful. It's wonderful if you're not Jewish. It's wonderful.
He's not Jewish, I am.
I just didn't know if that's not gonna feel good. You know, they can't like change it.
Can't do it.
Alright, let's go. Let's type these equations in.
Let's start with C.
Type them in. You type them in? I think you accidentally put a 2 pi instead of 2x. That's why your second one is 2. Okay, now look at your graph. Okay, so we're obviously zoomed way too far out. So here's what I would do. Do second table. And then look at your y line. Okay, 2, 3, 4, 5. So we don't need to be going to look at your window. Your y max is 170. So let's bring that down to like 8. Okay, now let's think about your, oh, that's okay.
Cross.
Okay, so it looks like they cross at like 2. So go back to your window and make your x max like, because you just don't need it that wide. And that should give you a better picture. Yep, you need the intersection. Good. Okay, we're working in. Yes, you need a calculator? Oh, you have a calculator. Yep, you got it. Okay, part A, should it be 1 integral or 2? 1. 1 integral.
I'm gonna do this question.
Oh,
Can I use the calculator or no? Yes.
just do it until next part. You just think about if you're gonna do it that way where you split, then you would have to have these solve for x. And that one. You should. I was saying if you have one or two. Okay, remember guys, that part A should just be 1 integral. Okay, Aaron, you find the intersection. You get a point just for that. For part B, I don't see pies or squares or anything.
Is it like where you have to find that? Is it too? Okay.
Oh, I was looking at your, I was like, you don't even have a pie on that. Hey, Sue. How are you? Oh, okay. It's probably okay. So if you're integrating dx, you already know your x is 0, so you just need that. So those will be your integral endpoints. You're not doing a dy though. That's where you need to know the bottom and the top values. You're just doing it normal to x. So it'll be from 0 to 4.
No, that's fine.
What's the area under? We still use the same.
Uh-huh. So set up an integral, A equals. Okay, you don't have to. 0 till, and then you need to find where they cross. And then your integrand is going to be, oh, you found it, yeah. So 1.487 is your x value on top. And then which function is on top? 4 minus 2x minus, and then the one on the bottom, yes. Because since you're revolving around the x-axis, remember that the bottom of your radius is 0. Okay?
Ms. Schroeder, what's the equation for A?
It should be A equals, bye Megan, bye Mark, 0 to 1.4 something. Yep, 1.4876, and then you would have done top minus bottom. So notice they already labeled them for you. 4 minus 2x is on top. X cubed over 1 plus x squared is on bottom. Dx. You don't want these to study.
What's that?
Okay, you should have gotten 3.214. Did you get it? Okay. Okay, sure.
Yes.
Which one goes first? The big one.
Because remember, like, you want to do the big volume and then minus the little empty 4 part. Because you're not adjacent to the
I'll bring the thing from yesterday during the practice school. That it's
Okay,
not
that's
up
fine.
there.
You can just give it to me on Monday. You just have to do it by the AP test. So,
From last night? I was bringing it to you. I'm
for B lunch, I'll be in this machine.
Well, see, I was just thinking.
C lunch, I'll be back.
That cheese balls are not okay to keep in your freaking head.
I'm missing a square, right? Since it's pi r squared.
Okay, how many R's in part B, guys? 2. Okay, so here's my region. Okay, capital R is from here to here. So it should be 4 minus 2x minus 0. Little r is here. And it should be your fraction-y thing minus 0. Then remember that your volume is pi integral 0 to 1.4876, and then it'd be capital R squared minus little r squared. Notice that since you're revolving around the x-axis, the bottom of both of those being 0, you don't have to put that. Okay, just to make sure we finish, you should have gotten 31.884. Yes, ma'am. Okay, part C real quick. Which way are we perpendicular to? So that means that when you draw your region, okay, I'm still here, perpendicular to that is top minus bottom. Very good. So it should have been right here. Okay, so your base of your region is 4 minus 2x minus x cubed over 1 plus x squared. Then what shape did they pick? It says we want the cross section to be a square. So it would have been area equals integral of the base squared. Okay? So 4 minus 2x, x cubed over 1 plus x squared. 0, 1.4876. Should I put a pi on it? No. No, squares don't have pi's in their formula, so you don't need one. Okay, and it comes out to be 8.997. Okay, thanks. And then one other thing, remember you only switch to dy if you're perpendicular to the y-axis or rotating around a vertical line like the y-axis. Other than that, just leave it dx. Okay, good job. Good, only one class period left. See some of you on Saturday at 12:15. Okay, can't wait to do math with you.
Wait, so what days are you here? Wednesday?